Welcome everyone to this LinkedIn Live hosted by Meltano. Brilliant to have two amazing speakers on. Alex, tons of knowledge on Iceberg. Mike, tons of knowledge and experience with Duck Lake. Meltano, we host these events to try and bring the technology to life and dig into like the real problems they solve, the technologies that the challenges that people face. And absolutely awesome to have you guys on. Thanks for joining us.
Thanks for having us.
Yeah.
A couple of introductions first, and then I'll put some questions to you guys. Alex, would you just give us we can see the hat, we can imagine where you're from, but please tell us a little bit about yourself and the technology space you're in.
Sure. My name is Alex Merced. I'm the head of DevRel for Dremio. I've been at Dremio for now 4.5 years, since December 2021. Where for the first several years, my focus was just really talking about open source, Apache Arrow, Apache Iceberg, Apache Polaris, Nessie, Apache Parquet. In that, I've gotten to write a few things. So several blogs on Iceberg and tutorials and whatnot, but also I got to be one of the co-authors on Apache Iceberg, the definitive guide from O'Reilly, Apache Polaris, the definitive guide from O'Reilly. And I'm about to have my third book come out from Manning, which is Architecting an Iceberg Lakehouse, which becomes available, I think it's May 15th or 29th or something like that. So yeah, that's me.
That's cool. Actually, really good book. I've got on my desk sitting over there. I've been flicking through it and refresher on all the technologies. It's still when was it published? It was a couple of years ago.
That was that was like 2023, I think. Was published, and then no 2024, and then Apache Polaris was published December last year. So each year a book.
So I still see tons of relevance in the book, and the technology space moves on pretty fast, which probably comes to you, Mike. Would you mind giving us a little bit of a background into your company and your space, and help us understand your kind of technology area?
Yeah, it's pretty nice to get like a pre-AI wave publication date, because like you actually did it. So that's
awesome. Wrote it.
Yeah, you actually wrote it. So I'm Mike Ritchie, founder of Definite. Definite's an AI native data platform. We kind of give you all the pieces that you would normally go out and buy and stitch together, or completely build yourself. So we have connectors to pull data in from your data sources, a built-in data lake, which is powered by Duck Lake, which I guess is part of the reason I'm here today. And then we have agents and analytics on top, so you can easily build dashboard reports, data apps, and then just get answers to whatever your questions might be for your business.
Yeah, that's thanks, Mike. You're right. You're here for the kind of Duck Lake experience, but also you've used Meltano in your technology stack, and we've used your connectors, and this is I see what you're doing, and I'm like super interested to dig into like the problem domain that you and the way that you see the world. Just a moment on us.
Well, that's one of the beautiful things with Duck Lake and Meltano. Like we actually, since they're both open source projects, we published a target for Duck Lake pretty early on, and I think it's still the primary one that's used. So if you're interested in using Meltano to write to Duck Lake, there's a target out there for you.
Yeah, and we have done actually. Like that was we've toyed with it ourselves, and it's robust and very good place to start from. So a little bit more about us then, and Meltano. We're bringing together conversations about efficiency. Like primarily, our lens is seeing an architecture where people are still moving everything into a data lake or a data warehouse. Lots and lots of connectors to maintain. That's a sort of primary problem to solve. And I guess my view of the world, talking to a lot of customers, is that AI and the kind of engineering space is game changing. Everyone can see that and can feel that in their jobs. I think what's kind of less talked about and maybe less obvious is the increased demand where the analytics, perhaps even users, are generating tons more query load. And I think that's kind of why I'm sitting here, with you guys, is like, let's look at that technology. Iceberg and Duck Lake are solutions to a problem. Alex, if you could start us off, what is Iceberg and what was the problem it was sort of intended to solve in its inception?
So I mean, bottom line, Iceberg is one technology sort of in a layer of sort of modern, what's referred to as open table formats. So essentially, the fundamental problem was you had sort of two choices. You had either you'd use like a data warehouse where you had to kind of first off migrate all your data into the data warehouse, and that worked. It was fast. But then if you ever wanted to use another tool, you'd have to go migrate that data to another tool. So you end up having multiple data copies. It was expensive. Or your other choice was a data lake where you probably put a bunch of Parquet files, but you didn't have like the consistency guarantees. So someone edited one Parquet file, they just broke the data set. Or if you wanted to change the schema, you'd have to rewrite it. So you had all these different sort of friction points. So these modern table formats, what they do is they create a metadata layer in between the query engine and the actual Parquet files. So that way, the way I like to think about it is like I'm Alex Merced, but really I'm just a bunch of cells and a bunch of like cells. But I don't think of myself as like cell 1, cell 2, cell 3, cell 4. I think of myself as Alex Merced. What Iceberg, Delta, Hoodie, Duck Lake do as a metadata layer is they allow you to think of the table not as Parquet file 1, 2, 3, or 4, but as the sales table, as the orders table. They give it sort of a consciousness. So now I can treat it with all the same kind of asset guarantees, but also with interoperability, so I can use it with different engines. So you fix all the problems you kind of had with data lakes and data warehouses in this new sort of data lakehouse paradigm. And Iceberg was one format that came out of Netflix that there's a more file-based metadata approach.
Yeah, and I think what was quite going back to your book, the use case around analytics and generally OLAP and the way queries are dealt with, way requests are dealt with, it suits structuring in a certain format. It suits structuring in a columnar way. It suits in built to query effectively, and a kind of asset guarantee on top of that is more challenging because it's not necessarily built to deal with that. So you see a lot of really great databases and solutions, but not necessarily separating that storage from update in a seamless way. Mike, perhaps you could give us Alex did a pretty good job of why the technology layer existed. If you have anything to add to that, great. But maybe a comparative, like why did Duck Lake come about? Like why was it that you saw it as a good tool for the challenges that you're trying to solve?
Yeah, I think of Duck Lake as Iceberg with hindsight. It's like if you had known every single problem that you would run into along the way, Alex, when did Netflix first open source it? It was late.
It was like 2017, 2018.
Yeah.
It was like when the first commits happened.
Yeah. So almost a decade of problem solution. And Duck Lake, the Duck Labs folks obviously had the benefit of seeing like all these problems that people had run into over time. And then also like having insanely deep database expertise and realizing like, hey, a lot of the problems that Iceberg has solved with files and the catalog and other approaches that scale really, really well. An interesting thing with Iceberg too is like you can run it completely off of a bucket, right? So like that, that was one of the original ideas is like, I don't want any other dependencies versus like just like an S3 bucket. So obviously that's evolved over time and, catalogs have been layered over top. But I think, the Duck Labs folks obviously having a pretty hard bias towards databases just thought like, hey, what if we solved all these catalog issues with a database from day one and just required that you have this one other piece of infrastructure, you have a database that's also part of your lakehouse. And I think you guys already mentioned asset guarantees a few times. Like our initial blog post on Duck Lake was called like, this is your lakehouse on acid. Like this, it's like, one way to approach the problem is to add a database in that just gives you all these guarantees for free that you don't have to design. You don't have to design around with when you're using like a file system instead. So that's kind of how I think of Duck Lake in a nutshell, is like understanding some of the problems people have bumped into with other open formats and taking, a slightly different approach.
Yeah, no, thank you. That's what I see as well. That's super clear. I wonder, bringing the conversation up slightly, closer to the benefits level. We mentioned open table formats, a few times. What I'm going to drill into is why would a company be interested in an open table format? Like why separate the query engine? Like why even bother doing all these things? And maybe it'll stick with you, Mike. You mentioned it. Why do you see that that's a good thing for your stack or for a customer that you work with?
Yeah, I mean, the number one thing that's important for us is maintaining control over the infrastructure. So we don't want to have like a third-party SaaS or a third-party tool embedded into our platform, right? Because that not only hurts our flexibility on like features that we want to develop, but also doesn't give us great control of our destiny on pricing and other things that we might want to adjust. So like we need total control over that compute layer. So that's the huge benefit for us. And then I think for our customers, it's a huge selling point because say they want an escape hatch. Like, and I think, this isn't a definite specific thing. This is a, Lakehouse or cloud warehouse specific thing is you want an easy story to tell around, hey, if I ever want to leave or I ever want to use another tool on top of this data, how is that done? And, depending on the format, like Oracle doesn't have a great story around this, right? For many of its products, even something like, Microsoft SQL Server doesn't have a great story around this. But open formats give you that story. And it's not, it's more than just a story. It's like insanely easy, right? Like, Iceberg's the same as Duck Lake, where if you look at the catalog, you can just see like, hey, it's basically just a list of Parquet files and I know how to operate on Parquet. So if I need to move it over somewhere or I need to, perform some operation on it, it's insanely easy to reason about.
Yeah. Alex, does that ring true? Like with what customers are using it in anger to keep control of their data and, sort of keep control of their destiny? I know you're working with much larger organizations typically.
Yeah, no, 100%. I mean, one is that every time you do a migration, it takes sometimes 18 months and costs a lot of money. So the idea is that if people are going to do another migration, they want it to be sort of like that last migration in a sense. And that's always the goal, right? But the tools change. So having table formats or having this paradigm of the Lakehouse where your data is independent of the tools that you use gives you a lot of flexibility. Because now if you need to migrate from tool X to tool Y, it's just a matter of pointing tool Y to your catalog. And with Iceberg, that's always been one of Iceberg's priorities specifically, because it was always a spec in the sense that it always focused on being a specification and not opinionated on what the catalog is, what the compute is, what the engine is. So in that case, that way it builds sort of these primitives in the way you write metadata and also the way the catalog works, that you can have multiple catalogs, multiple engines, which is one of the big reasons that people love Iceberg, is because you have such a wide, mature ecosystem of tools you can use with Iceberg. But the Lakehouse in general just offers this really nice place where you can have the scale that you want, but you also have the flexibility that you're future-proofed against the future, and you're not locked into any particular vendor. Like you might be locked in you might miss a feature here on the fringes of a tool that you're using, but you don't have to rewrite your entire data to move from tool A to tool B, and you won't even necessarily have to rewrite your entire metadata because different catalogs. You can just register your tables with a different catalog, and other tools can then discover the metadata all over again.
Yeah.
And like a concrete example that's like very relevant to this conversation is like the interoperability between Duck Lake and Iceberg is already, like, Duck Lake's very new. It's already pretty good. It's like, Iceberg has a list of Parquet files. You can add them to your Duck Lake catalog and vice versa. So it's for a very new open format, it already has that interoperability because of the way that Iceberg's built and because of the way that Duck Lake's built.
Yeah. So just drilling into that a little bit more, I can definitely see how without having to trawl through, petabytes of data would be a lot easier to migrate. Migrating just the metadata, just the catalog, sounds like a much smaller problem, probably quite nuanced, you imagine. But Mike is saying they're quite interoperable because someone's built a tool, or it's like, that someone's already had that problem, they've solved it in the community. Is that what you're kind of saying?
Yeah, so it's definitely early, but on Duck Lake's side, there's already work to, add a table from Iceberg and kind of copy over or read over that metadata. So there's already, feature work on that direction. And I know Duck Lake / DuckDB's roadmap is they're quite public about it. And that's a priority for them the rest of this year going into next year.
Yeah. Get that. What about the other way, Alex? Is there any sort of motivation to see tools in the market that goes from Duck Lake to Iceberg.
I would say if you take a look at the different tooling for interoperability, now again, there's different levels of interoperabilities. Interoperability between the different table formats, and then there's interoperability between the different engines in the ecosystem and tools that actually do the processing of the data. So when it comes to interoperability between table formats, oftentimes, and I think this is a statement to sort of like where Iceberg is currently in the marketplace, is that generally all the tools are typically, they come out of the camps for, like, for example, you have Uniform coming out of Databricks to kind of facilitate like interoperability between Delta Lake and Iceberg. Then you have what's now known as Apache X table, which was originally one table out of one house, which was to help really, or at least the impetus for it was to help interoperability between Apache Hoodie and Iceberg, because everyone oftentimes wanted their data in Iceberg, but a lot of these other companies had services that were built around Delta, or around Hoodie, or whatnot. So oftentimes there's interoperability with the other formats with Iceberg, but they usually come out of the other formats just because of the dominance of Iceberg currently in the marketplace. And then as far as like interoperability between engines, that's like a sort of different story. So like Iceberg, generally, you'll find pretty much every hyperscaler, every engine has some sort of Iceberg support. And then there's definitely different shades of gray. And then the other thing I want to point out is when people bring up performance, because again, regardless of whichever format you're using, it's metadata is what they're providing. The actual engine is what determines performance. So you can see huge differences between which table format performs better depending on the engine you're using. So always keep in mind, it's like, what tools are you using when you're choosing which format you have? Because different engines have optimized for different formats from the get-go, like, and how you cache that metadata, use that metadata. So, someone will say, hey, this format's faster, but it depends. Oftentimes it's really an engine dependent thing.
Yeah, I think that's a really good area to go into, actually. So I was at a conference, Snowflake Build, actually, big conference in London, and Snowflake was demonstrating its interoperability with Iceberg. Which is normal, you get that. What was kind of weird was that they spent the whole presentation showing Databricks, because it was must have been a better view to show the kind of Iceberg catalog building and Snowflake. So for that to be at a Snowflake conference, it's like super challenging to think, why wouldn't Snowflake want to lock you in? Like, how do they differentiate? And it really sounds like the query engine, the capability, all the infrastructure around it. It's quite hard then to for someone to make the right choice, or it's no longer about a format or a vendor. It's much more nuanced about these capabilities. I wonder how you guys see the world. Like, what's the kind of, is there a perfect space for Duck Lake or a perfect space for Iceberg? Or is it more like, actually, no, you do need to think about the next layer before you think about the perfect space? Mike, maybe you have to get your opinion on that.
I think it's a hard question, and I think it absolutely is. Unfortunately, it depends like scenario. It's like, who is on your team? What do they have experience with in the past? Do you have a team to be able to support? Because a really important piece to keep in mind is, although these open formats give you insane flexibility and really good performance, it is not a product, right? It's like, it's not something you're paying for and getting support and easily able to ping. So you're not able to easily have like a throat to choke, right? Like, it's like an open source project. So if you spin it up yourself, it's like on you to manage and on you to problem solve. So like, do you have the team in place to be able to do that? So I think like that would be the first question I would ask, is like, what, if you're making this decision for your company, it's like, what have people used in the past? What do you have experience with? And can you even support running something like this yourself?
That's probably super common across the kind of open source, open technology, across the board. And then probably like thinking about the questions that, CTOs, CIOs should ask. If the team's coming to them with, I want Iceberg, maybe Alex, what would you make them ask or encourage them to quiz their engineers on?
This is a perfect segue, because literally like the third chapter of Architecting an Iceberg Lakehouse, the upcoming book, is literally this. It's about how to do the audit. What are the exact questions you should ask? And honestly, like, the question shouldn't be asked. Like, if someone says, hey, we're looking into Iceberg, really the question should be asking, what is the reason that you want Iceberg? What is the problem that you're trying to solve? And the thing is that different teams are going to have different reasons. Because at the end of the day, when you're building a lakehouse, you're really intentionally trying to build an organization-wide data platform. So that way different teams, because what would happen in the past? We'd have like one department using like a Synapse with Azure, another one that's using like Redshift with AWS, and now they're constantly sharing data between each other. There's egress fees, all these costs, whatnot. Ideal world, they can keep using the tools they're using, but there's a canonical copy of the data. And that's sort of the reason why, one of the reasons why you want to go to a lakehouse. So in that case, you really need to get everybody on board with that change. Because like any technology transformation, if you don't make sure you get your stakeholders on board, that will affect the ability for you to get the adoption, to get the value that you want at the end of the day. So spending time not just with the end data analysts, but also the DevOps people who are going to deploy the platform. If you're deploying a platform or using a SaaS platform, getting together with sort of just all the different people who are going to be touching this platform in some way and figuring out, hey, what are their current problems? What do they like about the current platform? And what would they like in a better platform? Will help you sort of architect whatever you do end up building to get the maximum adoption buy-in, so that way you can get the quickest sort of basically march to value in there.
Yeah. Sort of thinking about what you're saying there, I kind of have a picture in my mind that like the predominant model has been one big data platform, one big lake of data. Like that's sort of the normal way we've all sort of expected data in an organization. In fact, that's most efforts have been going that way. But Mike, you said a super interesting thing in our kind of pre-call. We're talking about what topics would be most insightful today, and you were basically thinking more about the kind of edge compute use case where you have a little bit of the data that you seem to be saying that suited Duck Lake and DuckDB quite well. I wonder if you could. Do you challenge that idea that all your data should be in one place? Is that like still the predominant model, or do you think it's going to look a little bit different when AI is asking most of the questions?
Yeah, no, I still firmly believe in, and I think is what Alex was describing is like you need a central place. I think the use case that I've started to find extremely interesting is that if you have an easy way, which I think Iceberg has a good story around this, Duck Lake has a good story around this. If you have an easy way to pull down segments of that data that you are really going to be hammering with queries, pull it down locally or pull it down into a sandbox or pull it down into an environment where your agents are operating, it unlocks some pretty interesting use cases, especially around data agents. Like I would worry if I was, say, like, Capital One and I was already burning, millions and millions of dollars a year on Snowflake, and then adding agents to that feels like, okay, no, like that's like a hard no for me as the CTO, CIO. Because it's, when you watch Claude Code run locally on your machine, you can see the tool calls it's making. If you're running that against files, it's like zero cost, right? It's reading a file on your machine. There's a little bit of compute happening on your Mac, but does that bother you? Absolutely not. If you ask it a really hard question against your data warehouse and you start seeing that same thing where it's running 15 queries in parallel and some of them are taking 15 seconds to run, it's like all of these things are racking up, your credits are racking up your compute bill. So yeah, an interesting use case we've seen is that obviously going native on both Duck Lake and DuckDB is that it makes it really easy to pull down a segment of your data, pound a local DuckDB database that has that segment of your data. It might be millions of rows, it might be 50, 100 gigabytes, but there's zero cost and the queries are insanely fast. There's like 10 millisecond, 15 millisecond queries running locally, and you can kind of rest assured like you're not racking up a bill. So it's probably not an insanely common thing that we see right now, but it feels like one possible solution to the angst you might feel letting agents go wild on your data warehouse.
Yeah. And definitely a trend that like I'm keenly interested in. Like, there's probably at this moment, just a quick shout out to anyone who's listening. We do like the questions. If you have questions that you want to like dive in and like challenge the guys with, feel free to drop them in the chat and I'll get them to them, in a minute. Staying on the kind of AI query, AI type workloads, I've kind of been talking a lot about kind of 100 times more queries. And the more I get into it, I think maybe that's even like a total underestimate. That once agents start asking questions, there will be just a ton more questions. So the idea of a very expensive, highly governed, like central place, to call out, Snowflake as a technology, it's great at that central, but the cost and the infrastructure that goes around it doesn't necessarily suit this very chatty kind of AI workload. And Alex, I know that Dremio is like doing quite a bit of AI type, innovation and work in this space. How do you see the kind of increase in query load? Is it extreme level?
Yeah, I mean, some of our newer features are kind of really built around this, trying to build the not just the best Lakehouse experience, but the best AI experience around Iceberg. So the way I would put it is like the way we've thought about it is that there's three really major problems for like a lot of different AI projects. So one is going to be performance. So we do a lot with performance. Two, semantics. And then three, just having your data in a lot of places and the cost and time it takes to ETL that data. So with that, at its core, Dremio is a federation engine fixing sort of that silo problem. Two, like from a performance standpoint, our engine has been designed from Apache Arrow pretty much since day one. Like basically Dremio is 11 years old, Apache Arrow is 11 years old, and many of the co-creators of Arrow were either co-founders of Dremio or founding engineers of Dremio. So we have that, but one of the newest things we've done is called autonomous reflection. So imagine if you had sort of an algorithm that was kind of watching your queries and creating sort of like materialized views and cubes and managing them and decommissioning them for you autonomously. The benefit of this is, as you mentioned, there's more queries coming in, there's more varieties of queries, and the changes in those patterns are constantly changing. So it's much harder for like a manual data engineer to kind of create and curate, materialized views in the way like they would in the past and make sure that they clean them up. So by having this autonomous sort of performance angle, we're trying to make sure that, hey, our platform can keep up with the changing behavior and the increased amount of activity from AI. Because even internally, now that we're actually using our own sort of like our internal Lakehouse is Dremio, and we're using the AI tooling built within Dremio, and we've noticed a huge amount of extra usage from within the company from people who never really had direct access on the data before, leveraging that a lot more. And so far, it's all that tooling is working out as expected, but it's also the semantic layer that allows it where it doesn't send as many queries that you'd expect because it's getting to the right query faster versus having to do a lot of exploratory queries beforehand. So the semantic layer investments we've made have also been very valuable in making that efficient.
Yeah, definitely see that as well. That kind of, there's no substitute for good engineering. Even, AI is clever enough and can figure things out, but it might be massively inefficient to get there. You mentioned Apache Arrow, and not everyone on the call is going to know what that is. Would you mind just a quick segue into what Apache Arrow is for everyone listening?
So Apache Arrow is basically another standard, a standard for how to represent data in memory, specifically in a columnar way. So that way you can actually compress the data better. So the result is that you can have a lot more physical sort of like data in the same amount of memory for analytical purposes, and you can process that data a lot faster for analytical purposes. Arrow also covers how you transfer data between different machines, so that way you don't have to have the JDBC, ODBC costs where you're transferring data from columns to rows all the time. So it results in much faster data processing. So nowadays, originally it was like Dremio was all in on Arrow for the reasons I mentioned before, but now you're seeing it everywhere. You see projects like Apache Comet that are replacing the guts of Spark with Apache Arrow. You see Data Fusion, which is sort of like engine primitive, this open source engine primitive that you can actually use in a very similar way to DuckDB that is based on Arrow. There is all sorts of projects for a lot of other open source engines to start embedding them more with Arrow to use that fast processing.
Yeah. And this is one of the cool things about being in data. Like there is still innovations at the fundamental level that make a massive difference. And Mike, I don't want to put you on the spot too much, but I wonder how much you looked at the internals of DuckDB and what makes it different as a query engine. And a lot of people will be familiar with how much faster is it achieving certain things. Is there anything that you sort of spotted that it's doing that's like hugely innovative?
Yeah, I think it goes back to like the founding story of like kind of wanting to be able to run queries on a local CSV. So I think it was just like those initial decisions that they made And the team behind it, I think, like iterating from that initial vision is like what's made it different. And being open source, like there aren't very many, especially at the time, there weren't very many open source OLAP engines. And then to have it open source OLAP in memory was just like a very unique kind of almost strange combination. And I think it just kind of found its way into like so many different use cases. And I think the huge thing that DuckDB has benefited from, which like we wouldn't be using it otherwise, is that single nodes on the cloud have just gotten so big and easy to spin up that you can spin up an absolutely massive machine on GCS or GCP or AWS or wherever you want, and process data with DuckDB that would have been completely impossible like 5-10 years ago. So I think it's a strange, I think it's kind of a strange story or strange tale that they've been able to benefit from some things that are kind of like totally outside of their mission. Like being able to run DuckDB in the cloud was probably not at all in their minds initially, and now it's like one of the it's an insanely good option for running cloud queries.
Yeah, there's definitely a narrative that with the growth in machine size and capacity and cloud infrastructure, that suddenly you don't even really have to worry about the multi-node interoperability communication problem when you can just run like plausibly an organization's entire data in one single node. I suppose if we fast forward and look at the trend, it does look like organizations and the world is hungrier than ever for data. So I have to suspect this might drive something full circle where actually they've got more data than can be managed in a single node again, which is, this is what we're here to do, I suppose, as technologists, is keep solving problems. I wonder if there's any trade-offs that you can kind of spot in this particular choice. The looking after your own, technology, and I can see the question that Pacome is asking on the chat here is probably thinking along those lines. He's described it as a kind of full load run problem. So I guess this is more like the backfill or more like the federated data I'm kind of interpreting. What's your guys' views on the kind of limitations of the technology, where it is a really not a great choice to go down this path for an organization? Alex, might come to you first.
Yeah. I mean, honestly, I would say the biggest thing, and this is across sort of all the formats, is just sort of like the streaming story, because generally the way these formats work is that the commit happens after you write the files to Parquet. So in that case, there's always that latency of, hey, I have to write all this data to Parquet, then make a commit to whatever's being used as the catalog before the next query can actually see the data. So for the most, you can get pretty good latency on all the formats nowadays. Like most of them have made investments in being better for streaming. But when you're talking about like the really highest low latency, like the millisecond latency type use cases, it's still a difficult story there. And I think that's where like I'm excited about like Apache Iceberg v4, where they're doing things like trying to create like one file commits and things like that that'll help even further quicken the time that it takes to do quick writes to the table.
Yeah, and just to play some of that back to you to be more explicit, query response time, like latency on the query, like it's built optimal on that. Like that's that both formats. You're designed to solve that problem. But you're talking about transactions arriving, updates arriving. Being able to like instantly then see it in a query result. It's not built to solve that problem really, really well, which is understandably constraints.
Yeah. So I mean, I imagine there's some other interesting solutions coming down the pipeline. But yeah, that would be the biggest limitation I see. As far as like most other things, I feel like have mostly been figured out.
Yeah.
Or on the way.
And Mike, is your like in that particular problem domain, dealing with high volumes of updates or low latency of being able to see updates, is Duck Lake constrained by exactly the same architecture? Are they better in that regard? Having a transactional database to update the catalog, is that mean that they're slightly better at solving that particular problem?
Yeah, I wouldn't phrase it as better. It's definitely it's a different solution, and I think they have a clean story behind it where you Google this or ChatGPT it, but they have data inlining, which was actually included in I think the 0.1 spec, which is that it inlines it since it makes that assumption that you have a database as your catalog, it inlines small writes into your catalog database. And when you go to query that, it reads from there instead of reading from tons of small Parquet files. So if you're using, say, Postgres as your catalog database, so, small writes to Postgres are totally fine, totally performant. And when you go to execute a query against your Duck Lake, it's reading from your catalog. So it's actually pulling those small writes directly out of your catalog, which is, small, which would be, it may be in Iceberg, or if you're not using data inlining, it might be like 100 Parquet files, which is obviously inefficient to read 100 single line Parquet files. And instead of reading that, it's just reading directly from your catalog. You can use DuckDB as your catalog, in which case, the performance on that is actually pretty good. So if you're writing a bunch of small writes into there and then reading them back out, it works quite well. I would say the same thing as Alex, though. It's like not the best thing for millisecond latency real time analytics. There's other tools like Lakehouse and other places where that they're going to be stronger for real time analytics. But I think for analytics, if you drop the real time for analytics for any use case you have in mind, where a second or two latency is okay, which every one of our customers and almost every customer I talk to is totally. That's a totally reasonable expectation. It works great there, and I think Iceberg's probably the same way.
Yeah, and certainly in the analytics space, often days is fine, right? Like certainly next day is like very, very common.
Yeah, I mean, if you're looking at your Salesforce data, your Stripe data, your application Postgres database that you've synced in, it's like how frequently does that stuff change? Do you really need sub-second latency between the source and your lake? Yeah,
Alex, I feel like you're gonna make a point.
Oh, yeah, I was just gonna add one little detail about like the kind of inline when you see in the Iceberg space is oftentimes not necessarily in the Iceberg format directly, but different catalogs, because the Iceberg catalog ecosystem is diverse. Because again, not a very opinionated on what you use as your catalog or whatnot. So there's oftentimes the catalog that'll choose sort of what those caching mechanisms are. So sometimes some of that similar type caching happens there, or to the engine does. So I know like Dremio, we have like a query plan cache. So if you're running the same query in the same Iceberg table twice, and we know there's no changes, then we know, hey, the list of Parquet files that we pulled up last time doesn't need to be refigured out, or we may even have most of the Parquet files cached on the nodes. So different engines will deal with that differently with the other formats. I would assume that something like a Databricks Photon does something similar for Delta Lake. So there's what's really interesting though is like in the catalog specification for Iceberg, there is discussion about changing, because right now the way it works is you would contact the catalog and you have to get a list of Parquet files back. So that makes it hard to do sort of what Duck Lake is doing, where basically, hey, we're just going to go grab that list of Parquet files directly from the database. Although there are discussions about changing sort of what the response to some of those endpoints are, that could theoretically make it where Duck Lake could operate somewhat like an Iceberg catalog and actually fit within the spec. So I think as far as like where the interoperability between these formats comes in, most of my interest goes there is oftentimes in the evolution of the Iceberg catalog spec, because I think it will eventually make it, that catalog spec will basically carve out room for alternative formats.
Yeah. I wonder if you could dive into for a second the excitement around Iceberg and obviously the battle between Snowflake and Databricks and the kind of acquiring technologies. Is that still a space that they, looking back now, would make the same choices? I see you sort of, Mike, you feel like you're willing to dive in and have an opinion there.
Yeah.
Oh, sorry, go ahead, Alex.
Go for it. But okay, yeah. So basically, yeah, that's been an interesting couple of years watching that particular space of just seeing these like two behemoths sort of like kind of like, hey, we're gonna make this move in this direction. Let's see who can acquire the thing first. And then there's been, so basically first we saw this in the Iceberg bit with Tabular, and then we saw sort of like the Neon Crunchy Data bit the following year. But I think that was just an admission that Lakehouse has arrived in a sense, as far as like, more specifically open Lakehouse in the sense of like, hey, there's a desire for Lakehouse, but people want the flexibility and openness. And people were, I mean, Databricks wouldn't have bought Tabular if they didn't have people who they were doing prospecting against that were constantly asking them about Iceberg. Snowflake wouldn't have, opened up and started building Iceberg functionality. They didn't have customers asking them about Iceberg. So basically, to me, it's just a grander admission of sort of like the changing in the industry. Because again, for both of their businesses, they would have theoretically even better off if they stayed, kept people in their proprietary formats, whether that be Delta Lake or Snowflake tables. But the realization that they couldn't, that was no longer really the reality of the industry going forward, that people are making this move to this architecture regardless.
Yeah. Mike, if you want to add to that?
Yeah, well, I think, I wouldn't say Databricks started the war, but I think, based on their roots of having, operating on open formats early on, that's going to come up in sales calls, right? It's like they're, Databricks and Snowflake are going head to head on almost every deal. Every deal Snowflake cares about, I'm sure Databricks is trying to get into, and every deal that Databricks has, Snowflake is trying to get into. And when Databricks is like, hey, you can use open formats, on their call, and it's like, whether that's at the time early on, that was probably Delta and other other formats, and then that would come up on the Snowflake sales call. It's like, what open formats do you support? So I think enough rounds of that, enough reps of that, and Snowflake realized like they have to support one of these open formats, and I think Iceberg was the obvious choice for them. And then this not to pun it too much, but the snowball started rolling from there. It's like, okay, well, if we are supporting these formats, we need people that know how to use them, and people that are building on them. So that's where the acquisition started from. So it was pretty fun to watch. One of our top blog posts still is the Tabular acquisition, because like we just kind of I was like pretty shocked by it. It was like pretty interesting story to like watch it, sit and eat your popcorn, because obviously Snowflake wanted to do the same thing. So we still get a ton of traffic from that for some reason, because I think now that it's passed, people are like, wait, Tabular. Wait, why did they buy this? So it's look at the history there.
Yeah, exactly. Do you a bit more future thinking now? Like that's a lot of the movements around the kind of like open table formats. This kind of move to build like query engines that operate across different lakes and different formats. That seems like that's emerging. Is it going to be more in that space, or is it going to be more in the semantic layer space? Like you're just kind of now, I want your view on the data stack and where the innovation is going to be applied. Like, that seems like it's all AI driven, but maybe it's going to arrive somewhere else. Alex, what do you think about the kind of where the technology innovation is going to be in the next few years?
I agree that sort of like the immediate sort of like right now, what everyone's trying to do is build natural language analytics at their firm. They want to basically not have to wait 2 weeks for a report. They want to be able to type up a sentence and get a chart. So that's like, I think everyone's kind of investing in that direction currently. And I know we are. And again, our angle is just, again, making sure that you can connect as much of your data as possible with a performant Iceberg-based engine that has a semantic layer built in. So we're investing in those 3 specific areas. But I mean, there's other areas, I think, like, for example, it was mentioned earlier, the like edge, sort of like edge performance, I think is an interesting world. I know like Mike, you mentioned it earlier, and then I know like there's companies like Spice AI who are like looking into like edge inference and things like that as an angle for performance. And then there's also just I guess basically anything that makes getting to that endpoint faster or easier. And I mean, of course, that means getting the data into these formats. So again, that's where companies like Meltano and other projects play a very large role. So there's a lot of that, but I don't know, semantic layer or context, really. I wouldn't say just even say semantic layer, just different angles on context are going to be a big deal, because performance, efficient performance. Again, that because basically now we're going to start, now that you're not going to see as much subsidized tokens, you're going to want to be efficient with those tokens. So how do you get performance with efficient token usage? That's the thing.
Yeah. Okay, that's performance, efficient performance, and a bit more on sort of token usage, which probably boils down to cost as well. Mike, do you share that view, or do you think there's another space where the innovation might be applied?
Yeah, I mean, I think people are still figuring out like natural language querying, like how to actually get it to work. Everybody obviously has it in some version. Tableau probably has it. Power BI probably has it. So I think that that's still being figured out. Like the thing that I hear a lot from customers, and like I'm reaching pretty far back here, but I remember 2016, 2018, I was working at a fintech, and one thing I spent a lot of my time doing was writing hundreds and hundreds of lines of Python to be able to send alerts for specific scenarios. And that would just run, on a cron. It would find those scenarios and it would alert us when those are happening. And I think AI, obviously makes that really easy to do. Like you can set up all these alerts and get, understand what's happening in your company without logging into a BI tool or going and sifting through reports. So that's a lot of things. That's a huge piece that we're working on this year is how do you build this autonomous data team that's constantly looking at your data without blowing up your cloud bill, because you don't want an agent just running 24/7 exploratory data analysis from scratch every 24/7 that every 24 hours that it's kicking off and running petabytes upon petabytes of queries. So that's one thing I think that's going to be really interesting to watch. OpenAI put out a blog post about how they use data agents internally. And I think it's really good. It's the sort of infrastructure and setup that a lot of companies will want. It's bespoke. They've built it entirely for themselves, and they've had to write a lot of code themselves to build that infrastructure and build those agents. So I think that's one thing we'll definitely see more of this year is how do you run an autonomous data team that gives you the output that you actually need out of your data without blowing up your bill, without giving you tons of false positives on things you don't care about. So if you say you hook it up to some Slack bot and it's just constantly sending you information you don't care about, then it's worthless. Yeah. If it's missing really important things, then it's also slightly worthless. So how do you strike that balance?
Yeah, I think that resonates with me as well. Actually, the packaged agent architecture, everyone's building it now, so it sort of seems plausible that then becomes a sort of much more service as a service or some kind of packaged offering. There was that article in the news, I think it was today, that there's Uber said that they blew through their entire AI budget in half a year. And it's because, like you described, an engineer, maybe not even an actual data engineer, but someone who's looking at the data, sets off a workload that just churns and they chews through an awful lot of tokens in, very inefficient to try and achieve an outcome. And I'd be fascinated to look at the kind of effort, that cost versus result, now even versus 6 months, 12 months ago. That seems like it's trending in that direction of extreme usage, but maybe not extremely high value by comparison.
And it's so easy to do in data. It's even if you think of something as simple as the agent running a select star from a table to see what columns and the values are in there. It's okay, maybe it got 100 rows, which for a person is not a big deal. They're just glancing at their SQL client on their desktop. But that's dumping context and burning tokens every time you do it in an agentic workflow. So how you do that, how you deliver value without burning more tokens and more cost than it took in is an interesting problem space.
Don't know if either of you experienced the BigQuery and probably Snowflake to a degree, but the sort of runaway workload that some people have talked about, $100,000 query type things.
Yeah, the public data sets on BigQuery can easily hit you there. If you query one of the public, I know they have a Hacker News one, they have the taxi data sets one. I remember we were just running queries a few years ago against the public data sets, and we actually got hit that way too. We got a $3,000 bill from a single query.
Wow. And the size of organization, that's super painful. That's
it's just some ad hoc thing. We're oh, what are in these public data sets? Ran it, and it was next day you get this $3,000 spend alert on your ramp card.
I guess that's probably a point to dwell on for a minute. If that's one risk, the kind of runaway queries, are there other things that people should be guarding against? you can stay in the kind of table format space or further up the stack, like thinking ahead to kind of emerging problems. It feels like a useful insight for anyone listening.
Probably catalogs and just governance with like interoperable governance. So right now, like generally in the Iceberg world, you have a lot of catalog options, but just the way the catalog standard works currently, only the role-based access controls are really interoperable between different tools. So hey, if I have a certain rule in Polaris, Dremio runs a query, that rules will be adhered. If Snowflake runs a query, same restrictions will be honored. But they don't have that for like row and column yet. And I know there's a big discussion around that currently. So like, it looks like the way that'll work is that basically tables will have like a trusted engine to enforce their RBAC, and then they'll just kind of like send a request to that engine and say, hey, go check if this person has this access to these rows and columns. So that way, hey, if this is a rule that was defined by Snowflake, it could still be honored over there at Dremio because it'll know that go, hey, have Snowflake run the check before Dremio runs the query, kind of thing. So that'll be interesting because once you have really full governance, like true airtight governance that'll be the same across all tooling, that's a pretty big difference than the world we've been living in, where you're creating a lot of Baroque governance rules across different tools and having to audit that and make sure that it's all, it'll be easier to audit your security.
That was probably the space where like closed ecosystem, like the way they solved that problem is one of the reasons you sort of stuck in an ecosystem. Yeah. So if that becomes open, that seems like a pretty big change. Mike, any other risks that you can foresee if someone's headed down this kind of modern technology for open table formats, AI agents, kind of pick your space if you see any risks?
Yeah, well, I don't know about a risk, but I think obviously like with the rise of like vibe coding, like some projects and some capabilities are seemingly very easy to get spun up using an AI agent itself. So if you say you like spin up a data lake or spin up data infrastructure, kind of like vibe code your data infrastructure. I think the point Alex just brought up is like an incredible first foot gun, where it's like you spin up these things, don't fully understand them, and then realize like, oh, all of my HR data is public to everyone. Like everyone can see it in the company, or maybe everyone on the internet can see it, based on however I may have set it up. So I think those are still hard problems that like require human intervention and understanding and being able to set them up. So I think that like that's definitely not specific to data. I think it's like a general problem where like you put tools in people's hands that are insanely capable. They can obviously get, be way more productive, get way more done. But that first 80% is like really, really easy, like get that value out of and get like a huge kind of dopamine hit of building something. And then that last 20% of, even something as fundamental as like security and like roles and access. It's incredibly, it's not fun, right? Like that's the part that people like don't want to do. And it's difficult to reason about and get it right. So I think that's definitely that'll be an interesting thing to watch over the next year.
I definitely agree, and like you said, it can be applied to basically any domain. Like when you've got a tool this powerful that can build, it's still pretty hard to build something good. I feel like that's probably a really good point to leave it on. Probably just remains for me to thank you guys and really awesome insights, and then thank you for sharing that with us and really delving into the choices that people are facing on a day-to-day basis. And thank you for joining the call, and thanks for sharing.
Yeah, thanks for having us here.
Awesome.
Yeah. See you guys.